Let me first explain the problem. So there's a forest with an unknown number of rabbits. We ask n rabbits how many rabbits have the same color as you, and collected the answer in an integer array answers, where answers I is the answer of the ith rabbit. So it's really difficult to understand if you didn't check the examples. So let's just check the example. We're going to return the minimum number of rabbits that could be in forest. So let me first explain this first example. So for the first example, for such kind of a problem, it's better to use examples. Otherwise, you can never think about all the cases. And you can see I also make a lot of mistakes, and then I find my formula is wrong. Because this is a typically mathematical problem, but with the greedy idea, because we're gonna return the minimum number of rabbits that could be in forest. So let's first check this one. So there is two ones, so 1 and 1. So this one means I am a rabbit, and I know there's another rabbit which has the same color. So for example, I was red, and another rabbit, the color was also red. So this is the minimum. As you can see, this is a red. So it means this rabbit, my color is red. I know there's another rabbit whose color is also red. So it is straightforward. It could be the same color. This is gonna be the minimum. So in total, it's gonna be 2 up to here, 1 and 1. If it is not, so for example, my color was red. I know another rabbit whose color, let me put it outside, whose color is blue. And now I have another rabbit, maybe black. And I know another rabbit whose color is gray. So up to here, it has already been 4 rabbits in the forest, but we need to check the minimum. So if there is something like 1, 1, we need to use this red and red. There will be only 2 rabbits, but not 4 rabbits. So this is the greedy idea. If there's the same colors, maybe this one knows this one, and this one also knows that one. We know each other, so this is gonna be the minimum numbers. So this is the first example, and then we're gonna have this 2. So this 2 means there must be another rabbit, because there cannot be 3 ones. So if this is a still one, do you think that is possible? It is, but currently we're just analyzing this 2. For example, there's another one. So this 1 knows each other, and this one must know another rabbit. It means in total it's gonna be 4, but it's not 3. 3 is not possible. So this is why this kind of a problem is difficult. You have to analyze all the testing cases. Now we have a number of 2. So this means there must be another rabbit whose color must not be red. So maybe let's say just blue. So this blue rabbit knows 2 other rabbits. So I don't care what color it is. But the color must not be red. So this is a blue. Because if it is red, this rabbit knows those 2, and those ones also knows those 2. It would be something like 2, 2, 2. 2, 2, 2 is just means this 3 rabbit knows each other, but our case is not. It cannot be like 2, 2, 2. So this blue rabbit must know other rabbit may be black. So it means it should be 1 plus 2. So in total, it's gonna be 5. So this is the first example. It is explained exactly like that. So in total, it's gonna be 5. Let's check this number 2 was blue. Then there should be 2 other blue rabbits in the forest that didn't answer into the array. Maybe 2 other blue, or maybe 2 other black or other colors, but definitely not red. So this is the minimum. Now let's analyze the second case. It's gonna be really interesting. So let's analyze this case. So there will be like so the first rabbit, this one, I know 10 rabbits, and this one also knows 10 rabbits, and this one also knows 10 rabbits. And for other rabbits, it is in the forest, but I didn't ask all of them. I only asked 3 rabbits. So in this case, it means in total, there will be 11 rabbits. It's gonna be the minimum. So for example, I know 10 rabbits, myself 1 plus 10 other rabbits. And the second one, I know 10 rabbits. 1 plus 10. It is possible because in this case, if the 11 rabbits knows each other, if they know each other, so if I take 1 out of the rabbit, that rabbit must know all other 10 rabbits. So what is the maximum for this case? So what is the maximum? The maximum can be how many tens? It can be 11 tens. If there are 11 tens inside of the array, so I'm gonna return 11. That means we know each other. So this is a formula, and this is a formula for the case. How many we're gonna check how many tens. If so, for example, if the number of tens is less than or equal to 11, so we're gonna count it as 11. But what if there are 12 tens? But what if there are more tens? So this means before this is 11, and after that it's gonna be another 11. We need to plus 1 times 11. So 1 plus 1 times 11, it is 22. This is one case. But if there is a smaller, like only 3 tens, so it's gonna be just easier. We just use 10 plus 1, it's gonna be the result, because there are only 3 tens, not 11. It is less than or equal to 11. But what if inside it's gonna always be 0? So this rabbit knows 0 rabbit, and this rabbit knows 0 rabbit, and this third rabbit knows 0. So in total, how many? It's gonna be 3. This is all the case. So after analyzing all the case, so we're gonna use a data structure to solve the problem. So for this problem, I'm gonna use a counter. I'm gonna code the answers first. After coding the answers, I'm gonna prepare a result. Finally, I'm gonna return the result. So I'm going to check all the numbers because the number is just coming from 0 to 1000. So I'm going to check from 0 to 1000 because it is less than 1000. So I can check the values. So for I in range 0 to 1000, I'm going to check if this I equal to 0, result would plus equal to di. How many zeros? It must be di because I've already explained. And if it is not I equal to 0 because I equal to 0 must I inside the counter. If I in D and I equal to 0, it means 0 inside the counter, so I'm gonna count it. So elif I in D, still in D. Let me use the if I in D first and then check this one. I'm gonna use 2 if I in D, if I equal to 0, so my result would be like this, plus di. So elif, so this is I still in D, but I'm gonna check this di. If di less than, so for example this di d10 is 3, less than and equal to I plus 1, it is less than 11, 3 less than equal to 11. So what is my result? Result should plus equal to I plus 1. So this is 11. Else, so this means di is more than I plus 1. So this means there will be, there will be more tens, as I explained earlier. So the result would plus equal to, so the outside would still be I plus 1, but this I plus 1 should time value. It should be di. It's gonna count how many tens divided. I'm gonna use a cell. So the cell of di divided by di, for example, it can be 12 and divided by, I believe it is divided by I plus 1 is 11. So it's gonna be 2 times 11. This I plus 1 should be 11. It should be 22. I think this should be the entire code. I'm not sure. Just let's run it. It seems it is right. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases. And this problem actually, it is not so easy. Because basically we need to take care of all the testing cases. And for this one, you might forget about it after testing. Some testing cases, maybe this one is gonna have zeros, or you find there's an error, so you put it inside for the 0. And for this one and this one, normally it should be easier to analyze. If it is less than I plus 1, or if it is more than I plus 1, we just use the mathematical formula. And the idea is just the greedy idea, because we're gonna count the minimum. Thank you for watching. See you next time.